You can also put a star beside this one as another really typical, really important question that you'd like to understand. They give us something. They say, suppose secant theta is equal to 4. And we have to figure out all of the other 5 based on that. Okay? So first of all, they tell us it's between 0 and 180 degrees. The first thing you might write down is say, if I know that secant of theta is equal to 4, I know cos of theta is equal to 1 over 4. Next, if I want to draw a picture of this, I have to decide where this could happen. I have 4 quadrants. I could have an angle in standard position in any of those 4 quadrants. How does the question tell me which quadrant it's in? Well, according to the cast rule, the cast rule is with sine, cos, and tangent. So the secant really wasn't helpful here, but by changing secant of theta to cos of theta, 1 over 4, I notice it's positive. Cos of theta is positive in quadrant 1 and quadrant 4. So we have a possibility that I have an angle in standard position in quadrant 1, or I have an angle in standard position in quadrant 4. Either way, I can draw a line back to the nearest x-axis with a reference angle. Now this question in part A, they say from 0 to 180. In part B, they go beyond. So I'm going to draw both of them right now, but for part A, I'm just going to use this top one. And what do I know about this triangle? If I know that cos of theta is 1 over 4, and cos of theta is my adjacent side divided by my hypotenuse, I can label this side as 1 and my hypotenuse is 4. Same thing here, my adjacent side is 1, my hypotenuse is 4. I want you to do the mental math in your head. A squared plus b squared equals c squared. Careful, this time you know c squared. What is the length of the other side? Okay. Did you get square root of 15? Because if the hypotenuse is 4 squared, that's 16. You'd have to subtract the 1, and you get the square root of 15. Now that I've got my triangle labeled, once your triangle is labeled, this is the same as question number 3. You can easily write down the other ones. I can write down sine of theta, which is opposite over hypotenuse, and cosecant of theta, the reciprocal, just the flip. And I can write tan of theta, opposite over adjacent, and cotangent of theta, just the flip, the reciprocal, 1 over the square root of 15. Is it bothering anybody else how the smartboard this year, when I write something, sometimes it erases something else? Like that 1, can you still see it? But I think if I just like do a dot here, it, like what the heck? I don't know. It's bothering me just a little bit. Bet it's making things disappear. So there's part A. We determine the exact values of the other trig ratios, and it said only between 0 and 180, so that meant we didn't have to look at the 1 in quadrant 4. But now we need to find, to the nearest degree, all the possible values of theta, and they're looking in this domain. From negative 360 to 360. So, how do we find answers for theta? How do we solve for theta? We want to find, for example, we would want to find this angle. We would also want to find this angle. And we're going to want to find other angles as well, because there's going to be negative angles, because it goes from negative 360, so that will include these ones as well. Anytime we're solving and trying to find an angle, the most helpful thing for finding all of those angles will be your reference angle. So in B, we're always going to find our reference angle first. So how do we find our reference angle? Well, we have, in part A, we have a whole bunch of trig ratios. For finding an angle, you did that in grade 10 and grade 11 with like sine inverse and cos inverse and tan inverse. We don't have secant inverse, cosecant inverse, and cotangent inverse on our calculator. So probably we're going to use either cosine or tan. All three of them will work. Looking at them, I think I like one better than the other. I like the cos one because it has no square roots. Just going to save me a little bit of time typing on my calculator. That's the only benefit to it. Plus, second benefit, maybe I did a squared plus b squared equals c squared wrong. It's a possibility. I didn't write square root of 15 down right. It is right. Not like the 8 from before. But that is right. And so the cos theta is most likely the least amount of chances of making a mistake. So I'm going to find my reference angle. In fact, I'm going to write out cos of my reference angle. And a reference angle always deals with positive values. So sometimes you might have something in quadrant 3. You will still write positive values for everything because your reference angle goes back to grade 10 trig. It's an actual triangle with actual lengths. Can you find the angle? We're not worrying about positives and negatives here. So you would go to your calculator. This is what you would type in. So we're going to go to our calculator, type in cos inverse of 1/4. So second cos inverse 1 divided by 4. And we find out our reference angle is 75.522. And one thing that I do in my work, while I'm doing my work, is I try to avoid rounding early. I remember that usually we have to do 3 decimal places, so I write down 3 decimal places for sure. Sometimes I put that ... there to say, I'm keeping all of my decimal places right now because I'm not at the final answer. Final answers are usually to 3 decimal places, but this one, if I take out my highlighter, it does say to the nearest degree, so my final answers can be to my nearest degree. Now in the domain, they wrote the domain like this, which means from negative 360 degrees to 360 degrees. When you're thinking about angles in standard position always start at 0. They always start at your positive x-axis. So when I have a domain like this, in my brain, I'm thinking of the positive ones and the negative ones separately. The positive ones would be going from 0 to 360 degrees because angles in standard position start at 0. The negative ones would start at 0 and go to negative 360 degrees. This helps my brain connect it to my pictures. Okay? So when I go to write my answers, theta equals, I'll do the positive ones in blue. Well, in quadrant 1, can you see that your positive angle is exactly the same as your reference angle? So if it's 75.5 rounded to the nearest degree, that would be 76 degrees. In quadrant 4, because if I started at 0 and went to quadrant 4, how would I find the actual angle? I would go all the way around 360 and subtract my reference angle. So on my calculator, I can go and I can type 360 subtract this reference angle, and I kept all of its decimal places. I get 284.4. If I round that to the nearest degree, that'll be 284 degrees. So I can write that one in blue as well. Then in red, my negative angles. Well, this negative angle, can you see, is exactly the same as your reference angle. It's going to be negative 76 degrees. And this negative angle in quadrant 1, it's like going 4 quadrants negative. Can you see that it's like quadrant 1 is actually, in the negative sense, the 4th negative quadrant? So it's going to be exactly the same. And I didn't even have to do extra math here. I could figure out it was negative 284 degrees right away. All right, questions for practice. Circle 9, 10, and 11. And you start this one just like you start number 3. These are very important questions. And practice these a lot because they involve your cast rule, your reference angles, SOHCAHTOA, a squared plus b squared equals c squared. One of the things that makes trigonometry one of the more difficult units in grade 12 is just the amount of things you have to remember from previous years and make all of those connections together. Okay. Over the next couple of days, we are going to be doing a lot of color coding. So if you don't already bring a blue pen, a red pen, a black pen, and a pencil to class, or if you want to bring some other fun colors, make sure you do that over the next couple of days because we are going to be doing a fair bit of color coding.